All right, let's get started. Let's talk about money today. Money. Engineering econ is our topic for today. I want to show you something when it comes to the exam. Let me pull something up. So what I've been trying to do throughout these reviews is if you go to the back of the reference manual and you pull the exam specs for civil engineering, what I've been doing is I've been going through them one at a time. So topic number 1 was math, and then topic number 2 is probability and statistics. Topic number 3 is computational tools. So really what should be next is ethics. But I've decided to hold off on ethics for now for 2 reasons. I was just waiting. Yeah. Ethics, in all honesty, is a topic that doesn't take a lot of time to discuss. So it's something we can put off, and I really don't want to rush through econ. Econ is a very doable section on the exam. The questions are usually pretty straightforward, and it's something that with a little bit of practice and a little bit of work, it's something that can potentially be a slam dunk. So I want to give econ its day in the spotlight. Probably what I will do is combine ethics later with another topic. So like after econ, we're going to get into statics and dynamics. So statics and dynamics is going to be next week. I'm going to do those together because, and I'm going to spend more time on statics because if you look at the exam, there's more questions on statics. So you should be aware of that. So next week, we're going to do statics and dynamics. The week after, a little bit of that mechanics of deformable bodies. So we're going to do that one. All right. We may, like when it comes to mechanics and materials, I may throw a little bit of just material stuff in there as well. A lot of that's there's some overlap. Then we'll get into water. We'll get into structures. We will have a geotech lecture. We will have a transportation lecture. That one's, yeah. Probably when we cover ethics, I'll cover ethics probably near the end when I talk about construction and construction management. So because those two, they can go together pretty well. There's not really a whole lot of math associated with both of those. So I will not forget about ethics, I promise, but I'm going to put it off for now because the way that the topics are discretized, it works well later.
Questions in ethics, have we had those in any of the
Sorry, what's that?
Would we have had those in any class?
That's a good question. What I'll say about that is this, because you're bringing up an interesting point. So the question was, would we have actually covered ethics in another class? And the answer is probably not, because this is either here or co-op is where we cover it. Now, I do have a couple assignments that I'm going to give you all near the end of the semester, and one of them is actually going to be related to ethics, and it's going to force you to go into canons of ethics. So I'll probably treat that topic a little differently than I do all the others. Like, you say what you will, you've seen calculus before, you've seen probability and statistics before. I'll treat that a little different. So yeah. That's a good question, though. Any other questions? Okay. All right. Then let's get into econ. Okay. So first off, this is one topic above all other where you really need the manual. The manual will save you a lot of time on econ because of the interest tables. All of your discount factors and whatnot are all in the manual. So actually, I'm going to start with that. First, well, let me do this. Let me just mention that econ is not a very, very big topic on the exam. You're only going to get anywhere between 4 and 6 questions. But a lot of the computations are pretty straightforward. If I have $100 in a savings account and I put it in now at 10% interest in 5 years, how much money do I have? Those are really the types of problems you're going to get in econ. the way I'm handling the econ review today, I've got some practice problems that we're all just going to do together just to get us back into the swing of things with econ. And then I've got a few what I'll call real problems, and we'll handle it. But all of the calculations that I'm going to be talking about here today are pretty straightforward. The only thing that I would say is a little, I don't know, unique or different is depreciation, and we will cover that near the end. But other than that, I think you're going to find this is pretty straightforward. I'm going to handle these practice problems here in a second, but these practice problems are really just meant to get you back into the swing of things. So let me sort of take a step away from this. I'm here at the reference manual, and I am going to scroll over here on the left to engineering econ, and we're going to be spending a fair amount of time not only looking at this, but all of the interest tables over the next couple pages. Let me full screen this thing. Okay. All right. So first off, I know it might have been a while for some of you looking at this, but a couple things that I'll point out. In terms of what you'll expect to see on the exam, really you're more likely only going to see three types of dollar figure, or three types of payments, if you will, on the exam. And that is a payment or a deposit made right now, a present value, a payment or a deposit or a value in the future, a future value, or an annual deposit. So you might get questions like, if I want to withdraw 10 grand in year 7, how much do I have to put in every year? So it's asking you for an annual value or something like that. So as long as you understand what a present value is, what a future value is, and what an annual value is, and how you convert between the two, a lot of this is pretty straightforward. A couple things that you need to be aware of. Number one, on the first page of the engineering econ section are all of your discount factors. If you're trying to convert a future value to a present value, or a present value to a future value, or a present value to an annual value. I know it's been a while since you've seen a lot of this stuff, but I've got to believe that you have seen it at some point. Am I right? Okay. All right. Okay. All right. All of the formulas for all of those factors are right here. Now, a couple points about that. More often than not on the exam, you will not have to use the formulas at all. Okay? What I mean by that is this. For those of you who, it's been a while since you've taken econ, it might have been a while since you've seen these, but you probably do remember seeing these at some point. So the idea is you develop an interest factor table based on a given interest rate. So what I have here is a factor table based on an interest rate of 4%. So let's say I have a 4% that's compounded annually. So if I put in $100 into a savings account right now, and I have 4% compounded annually, what that means is that after a year, I've earned 4% on that. So if I look at my factor for 4%, for instance, F over P, I get 1.04. So that $100, if I multiply it by 1.04, that would be $104, right? So if I put $100 in right now, in a year, I'll have earned $4, so I've got $104. Everybody okay with that? And then a year from then, that $104 earns 4% interest, so it builds accordingly. So I guess the big point I would mention is that usually you won't have to compute those factors, because the manual lists a series of tables for common interest rates, I would say. So here's sort of what I would get at. Most of the time, you're not going to have to compute those factors, but sometimes you will. For instance, if I give you an interest rate of 5%, you're probably going to have to break out the formulas and compute them, because the manual lists interest rates 4% and 6%, but 5%, you'd have to go in and plug and chug. But again, all of the formulas are there. Now, when you use the formulas, remember your interest rates, so you refer to them in decimal value. So it's not 5%, it's 0.05. So just make sure you're aware of that when you're using the formulas. Don't worry, we're going to, shake the rust off actually right now. let's look at this a little bit. Okay, so I've got a few practice problems here, and these practice problems are really meant more to get us back into the swing of things. Okay, so let's look at this first one. So if I have a one-time amount of $500 put into an account and it's invested at 8% per year, what's the future worth at the end of 30 years? Now I'm going to ask a silly question. You think you're going to have more than $500 or less than $500? More. Oh, okay. All right. The point I'm making is that if you agree with that, then the factor you should be looking up is a factor that's larger than 1. Okay? It might seem silly, but using a little bit of common sense can help you determine whether or not you're looking at the right value, because it's really easy on the exam to look up P over F when you meant to look up an F over P. So that's really easy to mess up. So let's look at this first one. So if I have a one-time amount of $500 invested, and what's the future worth at the end of 30 years, really that $500 is what I'm investing right now. Okay, I'm putting that money into the account right now. So I'm going to term that a present value. So that's a present value of $500. Okay, and then this is invested at an interest rate of 8%. Is 8% one of the interest rates where the factors are already computed for us? Okay, so we don't have to worry about that. Okay. What? What'd you say? Page 142. Okay, page 142. All right. And then we're compounding over a period of 30 years. So our number of periods in this case is going to be 30 compounding periods. Now, in terms of what factor to look up, this is pretty simple, okay? We have a present value, and what we're asking for is a future value. So what we're asking for is the future, is the future worth, okay? Now, in order to compute the future worth, I have the present worth. So what fraction do I need to multiply this by? Well, what I'm saying is I need to multiply that by the F over P value, because you sort of think of it like fractions. The fractions will cancel, and that'll give you the future worth that you're looking for. And that's why the factors are termed the way they are. That's why they're called F over P or P over A or what have you, because you think of them like fractions. Just find the one that you need, and everything will cancel out. And they're termed, an F over P factor for a given interest rate for a given number of periods. So in this case, we need a F over P value for 8% per year for 30 years. So the present worth in this case is $500. And what is our value, or what's our factor? So what's the F over P factor for 8% for 30 periods? What is that? 10.0627. Now, right off the bat, does the value being larger than 1 make sense? Yeah, if I put in $500 in an account after 30 years, I'd like to think I was getting that money back, right? Unless it's like, Lehman Brothers or something. Nope, nobody got that. Okay, unless it was Enron. A little better? A little better. Okay, all right. All right. So what do we get when we plug and chug here? And 35? Okay, all right. And that's basically it, okay? It's pretty straightforward, okay? Everybody okay with this? Now, just so you're aware, if the value is a little strange, let me break out some Excel to show you how this works. Stop that, because now I'm going to start yawning. All right. Oh, I'm going to have to turn the pen off. Okay. So watch this. So year 0, year 1, year 2, year 3, and extend that all the way down to year 30. Okay, so the way this works, at the very beginning, at year 0, I'm putting in $500 into my account. Let's format that to where it's like a dollar figure. Okay, so what's the interest rate? It said what, 8%? Is that what it was? So after the first year, what's happening is I'm taking this and I'm adding that times 0.08, like 8%. So I'm earning money, right? 8% of $500 is 40 bucks, right? Well, after the first year, what's happening is I'm not earning 8% on 500, I'm earning 8% on 540, okay? So what I would do is I would copy that down, and so I'm not earning another 40 bucks, I'm earning a little bit more. And so you take that and you drag that down after 30 years, and there you go, okay? And that's the value that we got here. Well, 35, rounding. It was like we got 50, 31, 35. This is 50, 31, 33, just rounding and whatnot. And so that's what those factors are doing. They're taking that math and squinching it down for us so we don't have to compute interest over and over and over again, okay? Everybody okay with that? What's that? Fine? Fine. Fine. No, that's all right. Okay, now let's look at the next one. Okay, if you need to have $800 in savings at the end of 4 years, how much do you need to deposit today, assuming 5% annual interest? Okay, what's that? No. Go, follow that. Well, okay. So you're saying A over F. Well, a couple things. Number one, the over F is right because this is a future value. So the F should be in the denominator. But it's not an A because A would suggest how much do we need to deposit each year. Okay? What we're asking here is how much do we need to deposit today. So we're looking for a P value. Now let me ask you this. Whatever we compute, do we think it's going to be smaller than 800 or larger than 800? Smaller. So our quantity, our factor, should it be bigger than 1 or smaller than 1? Less than 1. All right, so let's see what happens. So we have an F value of 800. We have an interest rate of 5%, and we have a number of periods of 4 periods. So I propose then that we need to compute a present value, and we'll do that by taking the future value and multiplying it. In this case, I'm going to multiply it by P over F because the idea is the F's cancel, so I'm left with a P value. So IN. So we need an F value for P over F for 5% for 4 years. Okay? What's the problem? We don't have the 5% table, but that shouldn't be that big of a deal because we have the formula. Okay? So let's see what's going on here. What is that factor going to be? Here, let's write the formula out. First off, we know this is F. What is the P over F formula? One plus I to the minus n. Okay? What's so funny? Is there like laughing gas coming out of that vent? All right. So our future worth is $800, and then so we're going to have 1 plus. Now our interest rate, we treat that as a decimal in this case. Okay. So this is 0.05 raised to the minus 4. So if you want, you can say this is 800. 800. I'm getting ahead of myself. 800 times 1.05 to the minus 4. So what does that come out to be? $658.16. Do I have a second on that? 658.16. So maybe I'll underline those values. Okay. Everybody okay with that? All right. Now, let's look at the third one. Okay, so a company borrows 100 grand today on a 5-year loan. It's a 12% nominal interest rate, but it's compounded monthly. So what would the monthly payment be? So first off, let's talk about this. That 100,000, if we're borrowing that today, what is that? Is that a p-value, f? What is that? It's a p-value, okay? Now it's asking for a monthly payment. So what's it asking for? It's asking for a recurring quantity. And so that's A. Whenever you see a recurring quantity, you're talking about an A value. So so in this case, our present value is 100,000. And our A is what we're after. Now let's talk about this interest rate and the number of periods. Now, first off, what's the number of periods in this problem? 60. It's not 5, it's 60. Why is it 60? Because we're asking about a monthly payment, okay? We're asking about a monthly payment in this case. So the number of payments is 60. And if it's 12% interest annually, how much is it monthly? 1%. 1% each month for 12 months. So our interest rate, why did I put percent on the end? It wasn't box. You're right. So in this case, I propose that we're trying to determine a recurring value by taking the present value, multiplying it by the appropriate factor at the appropriate interest rate for the appropriate number of periods. So that's A over P for 1% for 60 periods. Okay? So that's 100,000. Now, do we have a 1% table? Okay, and what's the factor for 1% for 60? Okay, bless you. So that comes out to be $2,220 a month. So if you took out a 5-year loan at 12% annual interest, that's how much your monthly payment's going to be. All right. One thing to point out, there is a formula in your manual about what's your effective interest rate if you have like 12% compounded monthly. Now, you can determine that, and that's fine, but the difference is that formula would be more appropriate if you were going to make one payment per year. Where we're making one payment per month, we just change the number of periods and divide our interest rate by 12, and that's how we get equivalence there. So is everybody okay with this? Is everybody starting to feel a little more comfortable? That's interest.
Is that the same thing as APR? Or is that a different?
Basically, yeah. There's a little bit more going on, but basically. So I know this isn't the first time that you've seen the factors, though.
You just taught 4 months, in like 20 minutes.
I've never done it.
Why do you tell me these things? Okay, let's have a real problem. And I figure that the first word really in this problem would interest people. So the Powerball was won by a single individual. If that was me, I don't, would I still be teaching at Marshall?
You wouldn't know 2 weeks or so.
What? Yeah. That better be a pretty light Powerball.
You'll have a lot of students coming after you.
Oh, goodness. All right. The Powerball was won by a single individual, okay? Now, the individual is given 2 choices, okay? Receive 26 payments of $7 million a year, with the first payment to be made now, or receive a single equivalent lump sum payment, okay? So if the interest rate is 4% per year, what would that payment be, okay? So what I want to do is I want to bring up something that also should have seen in engineering economics, and that is a cash flow diagram. Okay.
That's the only thing I actually remember.
Now, did we know how to use it?
I had Dr. West tell me this.
Okay. What? You're gonna say those things. Make sure you're in the back of the room so the mic doesn't pick it up. Okay.
Oh, wait.
God. Actually, here, I'm just going to erase that off. Okay. So what I'm going to do is I'm going to start indicating some years on here. So we'll say this is year 0, this is year 1, this is year 2, year 3, year 4, year 5, 6, and I'm going to stop here. And we'll say 24, 25, 26. Okay. So what this is saying is it's saying receive 26 payments of $7 million a year with the first payment to be made now, or receive a single equivalent lump sum payment. So let's draw out what this is saying. What this is saying is 26 payments. So just watch this out. Okay, so here's 1, here's 2, here's 3, here's 4, 5, so on and so forth. And then here, here. Do I put 1 on year 26? No, no, you don't. Think. In year 3, how many payments have I made? 1, 2, 3, 4. So I don't want 1 right here. Okay? Everybody okay with that? All right. So, and these are payments of $7 million each. So, is this a P, an F, an A? What are we looking at? It's an A value because this is recurring every year. Now, here's the thing about A quantities. Here's the thing about annual payments, okay, in general, okay, and I'm going to sort of draw this up here, okay. Whenever you have an annual payment, so we'll say 1, 2, 3, 4, we'll say n minus 1, n, what have you. Whenever you have some annual payment, we'll say that that's A, and you want to convert that to a present value, the annual payments start in year 1. And so when you convert that back to, say, some present value, bless you, P, that converts back to year 0. So here's what I'm getting at. I'm saying that my A value in this instance is 7 million. But that only works for this. That bracket was horrible. Let me redo that. There we go. Okay. That is 7 million over 25 years. Okay. So here's sort of what I'm getting at. If I want to determine the present worth of this payment, here's what I'm doing. I think you'll be able to follow what's going on. Okay. I've got an annual quantity. Okay. An annual quantity. So I need to convert that as follows. Okay. For an interest rate of, what was the interest rate? 4%? Okay. But what I'm going to do is say that that's for 25 years. And you go, well, what about the one in year 0? What I need to do is add that remaining 1. Okay. Whenever you have annual quantities, they start in year 1. Where it was saying I have 1 payment starting now, I'm going to treat that as just a payment in year 0. I mean, here's sort of what I'm getting at. If I give you $7 million right now, how much is that worth right now? $7 million, right? Okay? Is everybody okay with that? All right. So here's sort of what we got going on. We've got 7 million times, what is my factor here? A present value, from an annual worth, 4%, 25 years. What is that? 15.6221. But all that's going to give me is that last 25 years. So what I have to do is I have to add that 7 million. And so in your calculator, you can just use 7. And so whatever the answer is, it's going to be that many million. So what does that come out to be? Sorry. So 116.35 million. Well, what this is saying is, if I got that every year, I'd be okay with that. What that's saying is this. That's saying I could receive $7 million every year starting now for up until year 25, or I could receive that right now, and it would be the same thing, equivalently, according to that interest rate. That's what that's saying. Is everybody okay with that? So remember, annual worths, they are annual deposits. They start in year 1 when it comes to your factors. All right. If that one was a little confusing or a little iffy, I think the next one I'm going to show you is going to illuminate or illustrate a potential strategy for how to do these problems, okay? Just in general, okay? Let me show you something. All right? If I have $10,000 that I've borrowed now at a 10% interest rate, the balance at the end of year 2, after payments of $3,000 in year 1 and $3,000 in year 2, are closest to what? One of the things that's kind of interesting about a lot of these problems is there's a very clear strategy sometimes how to do it if you are completely clueless. And one of the ways to do that is to get everything to present worth. Now, for this problem, I'm just going to be honest with you. That's not the most efficient way to do it. But I'm showing you this because when in doubt, this can work, especially when you have problems like this where there's not a lot of transactions or not a lot of dollar figures to consider. I have a $10,000 value now, and I have a $3,000 in year 1, a $3,000 in year 2, and that's it. Okay? So what I'm going to do is I'm going to convert all of this to present values. Let me show you how I'm going to do this. First off, let me draw my cash flow diagram. Okay? All right? So I propose I'm borrowing $10,000 right now, okay? And then I'm paying back $3,000 in year 1 and $3,000 in year 2. So this is year 0, this is year 1, this is year 2, okay? So just bear with me for a second, okay? Keep in mind, okay, the interest rate for this problem is 10%. Do we have a table for that? Yeah, there's a table for 10%. Okay. So what I'm going to do is I'm going to draw myself a little table, and I'm going to show you how this works. Okay, so let's look at dollar figure. Let's look at value. And let's look at present worth. And present worth, when I say present worth, I mean how much this is worth right now, okay? So let's start off with the initial loan, okay? Okay? What I'm going to say is this. I'm going to say the initial loan is $10,000, okay? Now, I do think it's kind of important to attach some signs, some plus or minus signs. So you can think of it however you want it. I don't think it really matters. You just need to be consistent. So what I'm going to do is say this. I'm going to say that $10,000 is positive. In other words, I went to the bank and I said, give me money, and they gave me money. Okay? So now I have money. I incurred cash. Okay, $10,000. I didn't go in there armed. I went in there with a loan application. So this might seem silly. What is the present worth of that $10,000? $10,000. Okay. Okay. What happened afterwards? Well, a year went by and the bank said, we're going to need to start paying some of that back. Okay. So we'll say my payment at year one. My payment in year one. Okay. So I needed to pay back some money on this loan. So what the bank said, I owed them $3,000 in year one. So that money came out of my pocket. I lost $3,000 towards this loan. So I'm going to treat that as negative. Okay? Now, here's where you got to put your thinking cap on. Okay? That's $3,000, but that's in year one. What's the present worth of $3,000? So if in year one it's $3,000, what is it in year zero? It's going to be less than that, right? This is a future value in year one. I want to know what the present value is. So what would I do? I'd multiply that by the what? P over F factor for 10% for 1 year. Because it's just 1 year getting it back to present worth. So what is that factor? 9091? Is that what you said? So what is this times 0.9091? 2,727.3? Okay, all right. If that's confusing, here's another way of looking at it, okay? That's negative. If I put that much money into a bank account right now, a year from now when I got to pay that bill, that's going to be $3,000. Does that make sense? That's why it's less, okay? Now, if that's the case here, let's talk about the payment in year two. Great question. Here, it's the P over F quantity for 10% for 1 year. So I'm going to direct actually this question at you, okay? In year two, I put in another $3,000 on that loan. But that was in year two. So what would be that value in year zero? What's the worth of that dollar figure right now? Am I going to multiply it by this quantity or the quantity in year two? So what's the quantity in year two? What's it? 2479.2. Do I have a second on that? So again, what that's saying is if I put that much money into an account right now, I wouldn't have $3,000 in year one, but I'd have $3,000 in year two. Everybody okay with that? So let's sum this up. What do we? If I sum this column up, what do I get? Yeah, just add these up. 0.5. Okay, so it might seem kind of weird, but what that is saying, that's sort of the present worth of the loan right now. So think about it. If on day one, the bank gave me $10,000, and then I put, as soon as I got that $10,000, I put that much into my account and that much into account, I'd be able to make a $3,000 payment in year one and a $3,000 payment in year two. That's what that dollar figure is saying. Is everybody okay with that? That's actually the present worth of that loan. But that's not what this is asking. What this is asking is what's the balance in year two? And that's where a present worth analysis is really easy to deal with. Because all I've done is I've taken all my payments and I've gotten them to present worth. Now all I have to do is figure out what's that dollar figure worth in year two. So in other words, what I'm going to do is I'm going to say P is 4793.5. I need to know what the future worth is at an interest rate of 10% for 2 years. So F is P, F over P. And so, nope, I got that backwards. What does that come out to be? Say it again. 5,800. Now, I'll go ahead and tell you, that's actually not the most efficient way to do this problem, but it is a straightforward way that can work for not just simple problems, but much more complicated problems. If you take all of the dollar figures presented to you in a given problem and convert it all to present worth, once you get that quantity to year 0, you can determine what the future worth is, what the annual worth is, whatever. You can pretty much figure out anything from that. Is everybody okay with this? I know I'm starting to ratchet up the challenge level a little bit. Anybody got any questions? All right. Wait, I didn't turn that on. All right. I'll just go ahead and tell you. This one's probably, if I had to guess, I'm going to take a look real quick. I think this is probably my most challenging problem here. Okay? So it gets easier after this one. All right? If a company wants to have 100 grand in a contingency fund 10 years from now, the amount of money that the company has to deposit in years 6 through 9 at an interest rate of 10% per year is closest to what? So it's probably not the worst idea in the world to draw this one out, okay? But before I do that, I want to put up a little image up here up top. Now keep in mind, the interest rate on this problem is 10%, okay? So we're still going to use that same table that we were just looking at, okay? I want to draw a generic cash flow diagram because I want to make some points about it. Okay, so, 0, 1, 2, 3, 4, 5, and then actually let me break that up a bit because I don't want this to go on forever. We'll say n minus 2, n minus 1, n. Okay. All right. So I want to talk about the way that those tables are structured because I think this is kind of important to understand what you're computing and why you're computing it. So what I mean by that is this. Those tables with the F over P and the F over A and all that and so on and so forth, they always assume that your present value, let's say, is right here and your future value is right there. So when you use F over P, I, comma, N, the N is referring to however far away that is. Okay? Everybody okay with that? Now, your annual quantities. Your annual quantities always start in year 1 and they always go to year N. So we'll say that. Okay. The reason why that is important is this. I want to lay out the cash flow diagram for this problem. Okay. So I'm only going to do years 0 through 10. Okay. Right off the bat, what the problem is asking for is we know that we want 100 grand in year 10. So we want, when it's all said and done, we want 100 grand right now. Okay? Now, in order to determine that, or in order to generate $100,000 in year 10, the company wants to put in some money in year 6, year 7, year 8, year 9. And the way I draw these diagrams, I usually draw money down as money going out of my pocket and money up as money coming into my pocket. That's just the way I look at it. So the 100 grand, I want that 100 grand at the end of year 10. I want that money in my pocket. But in order to get that money in year 10, I need to put some money out of my pocket in years 6 through 9. Okay. So really, what we're trying to figure out is this. Okay? Now, here's the rub. Okay? I want to go up here because I want to sort of explain what's going on. Again, this is probably the trickiest problem that we're going to have today. So everybody pay attention. All right? Annual worths are always defined from year 1 to year n. N being the total number of periods that annual payment is made. So, for instance, if I go from year 1 to, let's say that this is 15, that's 15 payments, okay? So I guess my question is, what would N be for this, first off? 4, right? Because there's 1, 2, 3, 4 payments, right? No, now how we handle that, I'm going to get to that here in a sec. And this is an interest payment, or an interest of 10%. Just write that down. Just keep that in mind. Okay. But here's the problem, okay? For our analogy, that future value right here, if this is my future value, that future value has to occur right here. It has to occur at the last year of that annual payment, right? Okay. The problem is that future value is right here. So here's what I'm going to do. I want to take this $100 or $100,000 in year 10, and I want to figure out how much it's worth in year 9. Okay, in other words, if I put the account in year 9, how much money would I need to put in to get $100,000 in year 10? Okay, so the way I'm going to do that is I'm going to say in year 10, I have 100,000 or 100,000. I wrote the one, it just didn't. So if in year 10 I have $100,000, in year 9, how much is that worth? So should it be more than 100,000 or less than 100,000? Less. If I put some money into an account, over time I want, that'll generate more money. So here's how I'm going to determine that. I'm going to say that 100,000, what I'm going to do is this. Essentially, that's a present worth calculation over 1 year, right? So basically what I'm doing is I'm bringing that back to a present worth at a 10% interest rate for 1 year. That's all I'm doing, okay? So what does that come out to be? Like I said, this one's a little bit more of the tricky one, but it's okay. 90,910. Second on that? So everybody pay attention up here on the screen, okay? Here's what I'm doing. I'm saying instead of $100,000 in year 10, I can also say that that is equivalent to 90,910 in year 9. Everybody okay with that? Because if I put that much money into an account in year 9 and wait a year, I'll get 100 grand. That's what that's saying. Sound good? Now let's look at this. Now this and this are starting to look a little bit more, compatible. My last future amount occurs on the last year of this. So what I can do is I can treat this as a future value, determine what my annual value would be. So in other words, my annual value is going to be my future value times the appropriate factor. So 90,910 for 10% for 4 years. And so what does that come out to be? Say it again. Do I have a second on that? So I think the best way of thinking about it is to sort of go backwards. What we're saying is this. If I put 19,000 some odd dollars into an account in year 6, year 7, year 8, and year 9, what I'll be able to withdraw is that much money in year 9, which is 100 grand in year 10. Okay? Is everybody okay with that? What we're talking about here, if you ever hear the expression or the term time value of money, have you ever heard that expression? That's what we're talking about here. This is what time value of money is. That if I put money into an account now, how much is it later? You know? And the idea is that over time, that either the debt or the asset is going to increase accordingly. Okay? Is everybody okay with that?
So you don't have to pull years 0 through 5 at all?
No.
So this is basic.
What's that? It's asking for how much you need to deposit in year 6, 7, 8, and 9. You can, now what you can do, if you are in doubt, you can take that 100 grand, convert it to present value, and then say, well, move it up to year 5 and figure out what the annual worth is. You can do that. And maybe you ought to, just to see, you know, just to get some practice with it. Okay?
So when you deposit that 19, the 19 you deposit is gaining interest, and then you deposit another one.
And it's gaining interest, and then the other one's gaining interest.
Okay.
Exactly, exactly. Does that make sense? It's crazy, isn't it? Yeah.
Is this like inapplicable? Like
This is a challenging one, I'm telling you.
realistic problem in the sense of like
This is up there.
why would you want to figure out, okay, 6 years from now, for 3 years, I want to make deposits only during that time?
The exam is going to test your knowledge of time value of money in general. This is a way of testing your understanding of that. Is somebody really going to ask you this question? In real life, probably not. But you do need to understand fundamental calculations regarding time value of money, and so this is a way of testing that. I gave you problems in structural analysis with hinges and triangular loads and all sorts of crazy areas. Some of them were very, you know, applicable. Some of them weren't. That's they can wait. Obviously, because I'm teaching. Like I'm actually working right now. Let's just stand up here. What's up? Nah, nothing. Just hanging out. Yeah, yeah. Is everybody okay with this? This is good. This is good. These are good questions to ask. And again, I will indicate this is the tough one. This is a pretty tough one. Okay? Everybody okay with this? All right. So if you are okay with this, let me express to you a problem that's a little bit more realistic. This is going to your question. Okay? This is a present worth analysis on a machine. Okay? Now, before we start getting into the math, I want to indicate that this is a very applicable type of problem that you will get on the FE. So let me sort of explain where this is going. We're only going to do one of them. We're only going to look at machine X, but we're also going to, what you could also do is look at machine Y and compare the two. Let me sort of explain. Okay, so let's take a look at machine X. Machine X has an initial cost of 66 grand. Okay, so on day one, I got to put out $66,000 to buy machine X. Okay, and then it'll last for 6 years. Okay, I have to operate that machine. So for those 6 years, I also have to pay, let's call them maintenance fees and operating expenses of 10 grand a year. So I buy it for 66 grand, and then I have to pay 10 grand a year just to operate it, which is kind of like buying a car. You have to buy a car, but then you have to put gas in it, you know, and you have to get the oil changed and so on and so forth. So you have to maintain that machine over, we'll say, 6 years. Now, after 6 years, I do still have the machine, so I could sell it, you know. Now, if I've owned the machine for 6 years, it's not going to be worth as much, you know, at the end of that life as it is at the beginning. So after 6 years, I can probably make about 10 grand off of it, okay? So what we're going to do for machine X is we're going to compute a present worth. Now, I put signs in here like negatives and positives. Sometimes on the exam you won't get negatives and positives actually put on the problem, but you kind of got to use a little bit of common sense. Like, I'm paying this, I'm paying that, and I'm getting that money back. So just handle it appropriately. What we're going to do is determine the present worth of machine X, and it's incredibly simple, okay? All we're going to do is this. We're going to say that the present worth of machine X is the following, okay? So first off, we're going to handle each of these one at a time. Let's talk about that initial cost. Is that a present worth, a future worth, annual worth? What is that initial cost? It's a present value. So what is the present worth of 66 grand right now? It's 66 grand, right? So what we're going to say is that's negative 66 grand plus, you know, something else. Now, why is it negative? Again, because I had to pay that. That came out of my pocket. So that's, you know, I'm losing money on buying that piece of equipment, okay? Plus, now what about that 10 grand? That's an annual expense, right? So I have minus 10 grand. Now here's the thing. This is like a present worth in year 0. This is an annual value. I can't add like an annual value to a present value. It's like adding apples and oranges. But what I can do is take that annual value and convert it to a present value at 10% for 6 years. Everybody okay with that? All right. Then the next one is, let's add that 10 grand at the end. Now, what's going on with that positive 10 grand at the end? What's that? That's the salvage, but what do I treat that as? That's a future value. So, and it's positive because that's the money I'm making, okay? So I need to bring that back to present worth, 10% for 6 years. So what do I get when you plug and chug all of this? Remember, it's all 10% and it's all 6 years, so it should be pretty straightforward. Is everybody okay with this? Like, am I going too fast? Yeah, not for year 0, but you would for year 1. Because, you know, on day 1, yes, exactly. Which is why you can just use the P over A quantity right now, because remember, annual costs start in year 1. So you've owned it for a year, and now you put down the cost to operate it. So, and that's negative, right? So first off, the answer to the question is C. But let's sort of delve into really why you would get asked this question, because you're going to have a question like this on your online quiz. What we have done is computed an effective present worth of machine X. So Think about it. That is the present value of what I'm going to get when I sell this machine back in year 6. That's me putting 66 grand on the table right now, and that's putting 10 grand on the table every year for the next 6 years. Everybody okay with that? Okay. Here's where the reality would come in. We could also compute a present worth of machine Y. Okay? So let's take a look at what's going on with machine Y. Machine Y costs a little less on day 1. I also make a little bit more money when I salvage it, but it costs a little bit more to operate, and its life is less. So if you are the person with the wallet, which machine do you buy? Do you buy machine X or do you buy machine Y? Well, it's not that simple just looking at the table, but it is when you convert everything to present worth. If you compute a present worth of machine X and a present worth of machine Y, you can look at the two values and say, well, if the present worth of machine Y is minus 120 grand, I'm going to go with machine X. That's less cost overall. Okay? Does that make sense? That's a real application. Okay? Everybody okay with this? This is good stuff. So you know, and to simplify and generalize, it's like, do I spend 50 grand on a dozer that's going to last 10 years or 100 grand on a dozer that's going to last 25 years? Well, it depends. There's maintenance costs and what I'm going to get for salvage and so on and so forth. So, everybody okay with this? All right, this next one, part of me doesn't even want to tell you how to do it. I just want to see what you can do. But this one is plug and chug, I will say. In fact, I'm going to see what y'all can come up with. I'm going to shut up. An interest rate of 12 years, 12% per year compounded monthly is close to an effective interest rate per year of what? If you had your NCEES reference manual in front of you, you wouldn't need to guess. I promise you wouldn't. How many of you have found it already? I'm just curious. Oh, see, we've got people raising their hands. What's that? Give you a hint. Go to the first page in the econ section. How many others have found it? There we go. We got more people who have found it. Does anybody have an answer for me? I'm curious. The suspense for the folks that are going to be watching the YouTube video is like insane. You know, you're actually probably right. That's probably what I would do too. Is like, I'm not going to sit here and listen to this. But here's the thing. I don't have like a, little window box that pops up that says skip to, minute whatever to find the answer. So. I could, but then I have to go all the way. No. That's a lot of work.
They might like this little break.
Anybody have an answer? 1268. It's D. Now let me show you why. If you go to the very first page of the econ section, come on. Right here, non-annual compounding, effective interest rate, right there. Even all the terms are right here. I'm throwing this problem in here for a very specific reason. It's very common on the exam to get a problem where it's literally, what's the, plug and chug, okay? We have an interest rate that is compounded monthly, so the number of, actually, hold on. Nope. I need to write on the slide because yeah. So our interest rate is 12% or 0.12. Our number of compounding periods within the year is 12 because it's 12 months. So therefore, our effective interest rate is 1 plus R over M to the M minus 1. And if you're like, what's going on here? I still don't understand. I'm going to show you here in a second. All right, so 1 plus 0.12 over 12 to the 12 minus 1. Another way of writing that is 1.01 to the 12 minus 1. And if you do that, you end up getting like 0.126825 or 12.68%. Now, if you're still looking at this and you're like, I still don't just understand what you're talking about. Like, I don't get what this compounding stuff means. Here's what's going on. Okay? It's not too bad. Okay. Just watch this. Let's say I got $100 in an account. Okay? And I have 12% interest, but it's compounded monthly. So each month, that's 1%. So if I have 1% interest, after the first month, how much money do I got? 101. And so I can do that by taking that dollar figure and adding it times 0.1, right? So after my first month, that's how much I got. How much do I have after the second month? 102 and some change, right? So what happens if I take that down to 12 months? What do I have? 112.68. So how would I have been able to figure that out without doing all this math? I could have taken just this dollar figure and multiply it by an effective interest rate of 12.68%. No, you could. You're right. But your interest rate compounds as well. See, hold on. Let's continue that out. Remember, hold on. Okay, so 126.97, I can take that plus that times, what was the interest rate? That, oh God. And then see? Because that interest rate builds. Remember, that 0.1268, it builds from year to year. That's what that effective interest rate is doing. Does that make sense? Yes. Oh, absolutely. Absolutely. Yep. Is everybody else okay with that? So again, that's all that interest rate is doing, when you're calculating an effective interest rate. If you're compounding it monthly, you're earning 1% a month, but remember that interest builds on itself. So after that first year, you didn't earn 12% because it compounded monthly, you earned a little bit more, okay? Have you all seen, do y'all remember, like, you compound it monthly, compound it daily, compound it continuously, where it's literally just compounding continuously? So you use the shampoo formula. You take the principal. Oh God. For continuous compounding, you take your principal and you take the natural base and raise it to the rate times the time. The shampoo formula. Shampoo formula. Yeah. Oh, shampoo formula? Okay, well, there you go. Oh, I love this job. Okay. All right. I got 2 more problems for you, and then we're going to call it. Any questions? Everybody's like, everybody good? All right. One final topic that I do want to discuss with you, which is something you really will see on the exam, is depreciation. Okay. Now there are 2 methods that are primarily used on the exam. One is just straight line depreciation. Another is using the modified accelerated cost recovery system, or MACRS. They're both really simple to use, and I'll show you how this works. So let's look at this one right here. So I have a machine that has a 5-year life. It has a first cost of 50 grand and a 10 grand salvage value. So I buy it for 50 grand and I sell it for 10 grand. Now we're using straight line depreciation to determine what the book value is in year 3. Straight line depreciation is incredibly simple. The idea is that every year I depreciate in value the same amount. Okay, so here's how this works. The first thing that we need to determine is the depreciation per year. Now there's a formula right there in your manual, and I'm going to use the notation, but this is really simple. And basically what it says is the depreciation in some year J, or what have you, is your initial cost minus the salvage value divided by the number of years. And honestly, if you're reading too much into this notation, you're probably doing something wrong. This is really simple. We take 50 grand, subtract it from 10 grand, and we divide it by 5 years. So when you chug this out, you get 8 grand. So here's what's going on. Okay, the machine has a design life of 5 years. So between that 5 years, it goes from a value of 50 grand to a value of 10 grand. So from a straight line depreciation, what we're saying is that it decreases in value 8 grand a year, right? So what's its value in year 3? How would you determine that? You'd take its initial value and subtract 3 depreciations. So that's basically it. So it's book value. Now I'm using the notation directly in the manual, but don't read too much into it. Its book value in year 3 is just the initial cost minus all your depreciation. And that's a minus, not an equals. So 50 grand minus 3 years worth of depreciation, and that's 26 grand. Everybody okay with that? This isn't that bad. Hopefully, I mean, this is really simple, like in terms of theory. There's really much theory to it. It's worth 50 grand in year 0. It's worth 10 grand in year 5. So every year we drop 8 grand. What's the value in year 3? Just follow it along. Everybody good? Okay. Now, the other method that is used more often in that's used just as often in engineering econ is the modified accelerated cost recovery system, or MACRS depreciation. It is very simple to utilize. It is based off of initial initial cost. So we have a machine that has a first cost of 50 grand and a 20 grand salvage value. So in order to use MACRS depreciation, you need your MACRS constants, which the manual lists. So if you go to the second page, so here's engineering econ. If you go to the second page, it's page 137 on the bottom and page 136, what have you, the PDF. I still don't know how that works, but okay. Here is basically your recovery period and recovery rates, and it lists different recovery rates for each year depending upon the number of periods. So, for instance, if you're looking at a 3-year recovery period, you start from the beginning to the end, and so on and so forth. When we're talking about year 2 and we have a 5-year recovery period, I'm only going to use the top 2 quantities, so 20 and 32. And if you add all these up, it's pretty funny how they all add up to be your total depreciation and whatnot. So here we go. Again, pretty simple. Honestly, what would be best is if you have the econ manual in front of you, or the reference manual in front of you, to sort of follow that along. All we've got is 2 years worth of depreciation. So we have a machine with a 5-year design life, and what's the book value at the end of year 2? So it's only undergone 2 periods of depreciation. Now, since we've got a 5-year design life, what is our MACRS factor? Well, for a 5-year recovery period, what do we have? We have a 20 and what, a 32, right? So that's basically the percent of our book value that we depreciate. So if I'm trying to determine my depreciation in each year, I would take 20% of 50 grand and 32% of 50 grand. So this top one, 20%, is going to be 10 grand. This one is going to be 16 grand. So after those first couple years, because we're using an accelerated cost recovery system, we've already lost 26 grand. So what's the book value at the end of that year? Well, it's the initial cost minus that depreciation, so it's 24 grand. So let me... Did I just like blow everybody's mind today? No. You all are selling yourselves short on that one. Yes. All right, hold on. Shh. Is everybody okay with this? Everybody good? Now, I haven't guys, I have not yet completed your econ quiz. My goal is to complete that. Oh, you can thank him for the problems I'm going to add to it now. Actually, I don't know. In all seriousness, the problems that I'm going to add to the quiz are what are considered to be the more challenging ones within econ, but honestly, I don't think they're that bad. If you understand or have a general idea of what I did today, you should be fine on the exam. So I don't want you to think that what's going to be on the exam is some mystery that you need to, just take it on, take a pass on and move on. This is not bad stuff. This is pretty straightforward, and I think you can do well on it. I will see you all next week.